Hi viewers, welcome once again to my channel, Israeli Math Concept. In this tutorial, I shall solve these two problems on the board. The problem is solved from NECO, and that is the year 2001. And that is question number 1B and C, respectively. If this is your first time of viewing, please kindly subscribe to my YouTube channel, Israeli Math Concept, so that whenever I drop a new math content, you will be notified. Alright, let me proceed with the solution to this given problem on the board. The B part of the question, we are asked to solve the inequality x plus one whole number 1 over 2x, and that is greater than or equal to 1 whole number 2 over 3x minus 1 whole number 1 over 6. Then the C part of the question, we are asked to show the result on a number line. So first thing first, we solve the B part of the question, after which the range of value we get, we then represent it on a number line. Let's proceed with the solution to this given problem. Remember the question for the B part of the question, we have x plus 1 whole number 1 over 2x, and that is greater than or equal to 1 whole number 2 over 3x minus 1 whole number 1 over 6. All right, looking at this inequality equation, the first thing we shall do is to convert the mixed fractions to improper fraction. And doing so, we have x plus 1 multiplied by 2 is 2, and 2 plus 1 is 3. So we have 3 over 2x. And that is greater than or equal to 1 multiplied by 3 is 3, and 3 plus 2 is 5. So we have 5 over 3x minus 1 multiplied by 6 is 6, and 6 plus 1 is 7. So we have 7 all over 6. All right, we can clear the fractions because this is in fractional form. And to clear these fractions, we should first of all ask ourselves, what are the denominators we have? The denominators are 2, 3, and 6, respectively. And the common LCM of the denominators, which are the 2, 3, and 6, is 6. So we multiply through by the common LCM of the denominator so as to clear the fraction. Hence, we have x multiplied by 6, which is the common LCM of the denominator, plus 3 over 2x multiplied by 6, and that is greater than or equal to, we have 5 over 3x multiplied by 6, then we have minus 7 over 6 multiplied by 6. Such that x multiplied by 6, we have 6x plus 2 divide itself is 1, and 2 divide 6 is 3. And 3 multiplied by 3x is 9x. And that is greater than or equal to 3 cancel out itself is 1, and 3 divide 6 is 2. Such that 5x multiplied by 2, we have 10x. Then 6 divide 6 is 1, and 6 divide 6 is 1. And negative 7 multiplied by 1 is still negative 7. And that is very simple to do. If we then collect like terms, we then have 6x plus 9x, then positive 10x crossing over to the left-hand side of the equation, it will change to negative 10x, and that is greater than or equal to, we have negative 7 remaining at the other side of the equation. Then 6x plus 9x will give us 15x, and 15x minus 10x will give us 5x. So we have 5x is greater than or equal to negative 7. Then when we divide both sides of the equation by the coefficient of x, and obviously the coefficient of x is 5. So dividing both sides of the equation by 5, which is the coefficient of x, then 5 we divide 5, and there are 1, 1. We are left with x, and x is greater than or equal to negative 7 divided by 5, we shall have negative 1.4. Then we are through with solving for the B part of the question. Let's also take the C part of the question. We are asked to show the results on a number line. And obviously, this is the result of what we solved already. So to represent this result on a number line, it is very simple to do. This is the C part of the question. Then let's draw a straight line first. Then indicate the center of origin as 0. Then remember, this is our positive x-axis, and here is our negative x-axis. Then looking at the value we have here, we have negative 1.4. So whatever value we should put in this number line, let it not exceed 2. So if I'm considering 1 centimeter to represent 1 unit, so from this point to this point is my 1 centimeter representing 1 unit, another 1 centimeter automatically will be 2 units. And the same thing I just did here, I will also do for here. So I have negative 1 because this is the negative axis. Then the next 1 centimeter will be negative 2. Then remember, the next thing is to trace this negative 1.4 in this number line. How do we trace it? Very simple. Since I already know that from this point of 0 to this point is negative 1, and from this point of negative 1 to this point is negative 2, hence in between negative 2 and negative 1 lies negative 1.5. Yeah, that is true. Then we also can trace negative 1.4 at this other part of negative 1.5. So at this point we have negative 1.4. So I can now put a kind of dot and shade it. This dot I shaded is because I'm considering a weak inequality. Remember that an inequality of the form greater than or equal to and less than or equal to, we call both of these weak inequality. So they are weak inequality. And when we are drawing a number line and we are trying to reference to weak inequality, that dot we should put should be shaded. Then for strong inequality or strict inequality like greater than and less than, we call them strict inequality. And whenever we are considering a strict inequality of greater than and less than, we are just using an open dot that is unshaded. But when we are considering for weak inequality, which is greater than or equal to and less than or equal to, we use a shaded dot to represent it on a number line. So having known that, remember I said prior, this is our central point of in between negative 2 and negative 1. So in between it, we have negative 1.5. And then before negative 1.5 lies a point of negative 1.4. Then I will trace it up and then I will shade it. Then after shading it, remember that our range is that x is greater than or equal to negative 1.4. Hence, since we are considering for the range of x, which is greater than or equal to negative 1.4, automatically our direction should go this way. Because in this direction lies all the values that are greater than negative 1.4. And since here is our negative 1.4, every other values that we proceed in this negative x-axis should now be less than or equal to negative 1.4. But any other values that proceed in this positive value should lie on the greater than or equal to negative 1.4. Alright, this is basically how to solve a given problem of this kind. Thank you for viewing, thank you for watching. Remember to subscribe to my YouTube channel, Israeli Maths Concept, and also to hit the notification bell so that whenever I drop a new maths content, you will be notified. Goodbye.